Good morning. Myself DIVYA and my project title is Fault Indulgent in Embedded Memory using Wcet by Rtos. Abstract. In today's scenario, the density of integration and the increasing percentage of system-on-chip memory occupied by the embedded program have led to an increase in accepted amount of power and memory consumption. In order to reduce the integrity and of the embedded programming, the Wcet technique has been implemented. By monitoring the worst case execution time, we can reduce the clock cycles required by each instruction of the program, but analogously increases the memory and the time consumption based on both Ram and Rom memory and the delays from the nodes in the embedded system and also the power consumption criteria. In this project, I am going to use Heuristic algorithm is by an application in a Raspberry Pi microcontroller to obtain a results in worst case execution time. Objective of my project is to attempt a fault tolerance technique Wcet, that is worst case execution time by Rtos real time operating system in an VMP chips. This is my block diagram of my project. The right side that you see is an Raspberry, and we give an input to a Raspberry through an A to D controller converter. We have two sensors, temperature and humidity. By U-boot we can use this system in Linux. This is what Raspberry is. It is a credit card sized microcontroller. It will be shown in Linux software. These are some configuration of Raspberry Pi. We have 5 booting phases: RAM loads, X loads, all those things. But the way I am going to boot is U-boot. These are the commands used in U-boots. This is how we connect to U-boot in Linux. This is an diagram for worst case execution time. In y-axis we have PDF, and in x-axis we have execution time. In typical execution time is shown in the left side of the graph. We don't have any confusions or any problem in those things. But in worst case, what happens is the PDF becomes 0. So it's a problem for us. So to rectify that, I am doing a project. This is how Wcet has been estimated for a simple delay example. We could see a real-time application for real-time something. The yellow color shows for measurement, and we cannot differentiate between worst case and the best case. In simulation, somewhat we could distinguish the worst case. In doing analysis only, we could justify that this is an worst and this is an best condition. In comparison with the other controllers with Raspberry Pi, we could by this comparison I could show that Raspberry Pi is best for my project. Heuristic algorithm definition and the example. Heuristic refers to an experimental based technique for solving problems, learning and discovering that gives a solution which is guaranteed to be optimal. Not guaranteed to be optimal, where the search is impractical, and the heuristic methods are used to speed up the processing of finding a satisfactory solution via method shortcuts to easily the load of making a decision. So this is a funnel diagram for the heuristic algorithm. In starting, we have lots of tokens. We have to segregate those tokens by using heuristic algorithm. This is a flowchart of my algorithm. We'll start it. We'll get the information from the application, and we'll check that those data are there in the cache. If it's there, we'll end the process. If it's not there, if it goes to an worst case, then we have to do the process with the algorithm. These are some of the steps for a simple example GDC. A single checkpoint overhead. This is for a single node how the time has been taken. The left hand shows for the other algorithm, greedy algorithm, and the right hand shows for the nodes that has been taken for heuristic algorithm. The time difference is very low. There is a comparison between a greedy and heuristic algorithm, and this is compared result. By this I could say that my algorithm is better and the best compared to other algorithm. These are some of the parameters that I am going to analyze with these formulas. By correlation and autocorrelation only we are going to find the worst case and we are going to display the outputs. Simulations. The PuTTY software for used in Linux for showing the LAN connection and to between the Raspberry and the monitor. This is a Linux screen for Raspberry Pi. This is how the device has been connected through IP address. VNC viewer, virtual network viewer, Raspberry Pi screenshot. This software spectrum of a Raspberry Pi in in this idle one we will write the programs and we will execute it. Simulations. This is a snapshot of a Raspberry Pi. This simulation solution. This signal has been taken in worst case, and in normal case the signal would be this one. And for the analysis, this is standard deviation of the normal signal. This is standard deviation in the worst case. We could see a large amount of difference in this. And I have one more FFT analysis in worst case. That's my project. Thank you.